Hello, this is lesson 1.2, polynomials. The general form of a polynomial is This is the general form of a polynomial. In here, a n minus 1, and so forth, a1, a0, are numbers, real numbers. Here, the exponent n minus 1, this is exponent 1, this is exponent 0, x to the exponent 0. So these exponents must be positive integers. It cannot be a fraction. It cannot be negative number. It cannot be decimal number. It must be positive integers. Let's have an example. This is a polynomial. You see, the exponents is a positive number. This is a positive number, positive integer. This one is a positive integer. And these numbers, here, this is 1, negative 7, they are real numbers. This number is called leading coefficient. Negative 5 is called leading coefficient. The 4 is the degree, you call degree. The 4 is the degree of the polynomial. Degree refers to the largest power. This is largest power. This 2 is smaller than 4. 4 is the largest power. And we call this the degree of the polynomial. This is another function, but this is not a polynomial because this term, you can rewrite this as x to the exponent 1/2. But 1/2 is not an integer. Therefore, this is not a polynomial. So we have discussed the condition of a polynomial. We go back to the general expression. Look, this polynomial function has variable y, variable x. So x and y are two variables. So I can give different values of x and then calculate the corresponding values of y. This means I can have the so-called table of values. Once I have a table of values, I can draw a graph. Therefore, a polynomial function can be represented by a graph. So the next part, I will talk about when a polynomial function is given, how do I draw a graph? Okay. Let's have an example. This is a polynomial function. If you expand this, then you have many terms. Each term will satisfy the condition of a polynomial. In other words, the exponent, after you expand it, the exponents of each term is a positive integer. And the coefficients, all these, you see 4, -1, 5, 2, all these are integers. So you have integers as coefficients. So this is a polynomial. And I can do a table of values, and I can graph it. But there is a short way of graphing it. when the polynomial is in the bracket form, it is convenient to draw a graph if the polynomial is factored into a factored form. Let's find x-intercepts. The x-intercepts can be found by letting y equal 0. So I can let this be 0 and find the x-intercept. So the x-intercept, this is equal to 0. The x-intercept is -4. This bracket is 0. The x-intercept is 1, +1. This bracket is 0. The x-intercept is -5/2, which is -2.5. So once I know the x-intercept, I can draw a rough graph. Now what about the y-intercept? The y-intercept, you let all the x to be 0. So this 0, this 0, this is 0. So I have -1 times 4 times 5, which is -20. So y-intercept is -20. So this is x-intercept. X-intercept, I have this, and y-intercept is -20. So I can draw the graph now. -4, 1, -2.5. Okay, maybe here. These are the three intercepts, and y is -20. Okay, 1, 2, 3, 4. So suppose this is -20. So my graph passes through these 4 points. How does the graph look like? This is the graph. And this is 0. So this is my graph. It's just a qualitative sketch. Okay. You label all the intercepts and graph that. How do I know I start from here? I start from here. How do I know? Can I start from here and draw like this? If I start from here, draw like this, I cannot pass through this point. So I must draw from this corner. Another thing which decides whether I start from the first quadrant or fourth quadrant is this. X times 2x is how much? X times 2x is 2x cubed. So the leading coefficient is 2. It's +2. Because it's +2x cubed. the leading coefficient is positive 2. Then this quadrant is when the leading coefficient is positive. On the other hand, if the leading coefficient is negative, we start from the fourth quadrant. So this is this example. Let's have another example. Let's see now. Okay. Just like what we did for the first example. First, we find the x-intercept. The x-intercept is, this is 0. So x-intercept is 0 here. And when this is 0, x-intercept is -1. I only have 2 x-intercepts. This is slightly different from the first example. Let's go back to the first example. The first example, I have 3 brackets. Each bracket, the exponent is 1. 1 here, 1 here, 1 here. But for this example, here is 1, but here is 2. So it's slightly different. We call this 0, order 2. This is the order number, order 2, for the intercept 0. So the graph, I have 0 intercept, -1, 0 here, -1 here. X squared times x, it's x cubed. This x cubed is 1x cubed. So the leading coefficient is +1. So I start from here. I must pass through this x-intercept and pass through this x-intercept. By the way, what is my y-intercept? Y-intercept, you let x equal 0, then everything is 0. So y-intercept is 0. So I have 2 points. This is both x-intercept and y-intercept. My graph must pass through this point and this point. But remember, this point is order 2. I start from here. I must pass through this point. For order 2, I do not cross it. I do not cross this point and go down. No. For order 2, I just touch it. But this is order 1, you see? This is order 1. Order 1, I need to pass it. I need to cross it, okay? So this is the graph. This is order 2. Okay, So that is the graph. Yeah, that is the graph. Let's have another example. Let's see now. Let's choose an example. Let's see this. Let's see this. All right. Let's have another example. Y is equal to x to the power 4 plus x. Now, this is not factored yet. As I said, if you can factor it, it's easier to see the graph. So I can factor out x. This can factor further. This is a cubed plus b cubed. So a cubed plus b cubed can be factored. So this gives the x-intercept 0. This gives me x-intercept minus 1. This does not give me any x-intercept because b squared minus 4ac is less than 0. b is negative 1. A is 1, c is 1. So negative 1 squared minus 4 times 1 times 1, which is less than 0. So no x-intercept. Only x-intercept are these two numbers, 0 and negative 1. So I have 0, negative 1. What is a y-intercept? I let x equal 0, y is 0. So this is both x-intercept and y-intercept. This is very similar to this graph as far as the x-intercepts are concerned. So this, but it is different, okay? The functions are different. How do I graph this then? This, the leading coefficient is 1, is positive. So I start from here now. The exponent is 1 here. Exponent is 1 here. So I cross this x-intercept. I also cross this x-intercept. This is looks like something like this. Okay, it's difficult to draw, but the result is this. Okay, cross this point and cross this point. So this is the graph. If you are not so sure the graph, the shape of the graph, you need to do a table values. table values will give you more accurate drawing. Okay. Do we have more example? Let me see this. Okay, so let's have another example. Okay, so you have this right. Just look carefully. This graph looks like that. Yeah. Two x-intercepts. Y-intercept is 0 also. This part has no solution, so two x-intercepts. The graph looks like that. Another example. This can be factored. I can factor x squared. This bracket can be factored further. So I have therefore I have three x-intercepts. This gives me x-intercept 0. This gives me x-intercept -1. This gives me x-intercept +1. So, how does the graph look like? Zero, -1, +1. What is a y-intercept? I let x is 0, so y-intercept is 0. So what? This is both x-intercept and y-intercept. Look, this is order 2 here. Because of this is squared. So x equals 0. This x-intercept is order 2. Order 2 means you cannot cross the x-axis. You just touch the x-axis. The leading coefficient is this. This is 1. And the leading coefficient is positive. So I start from quadrant 1. I pass here, touch here, pass here. Let me use the word cross instead of pass. I cross this point, cross the x-axis at this point. I touch the x-axis at this point. And I cross this point, cross the x-axis at this point. So this is my drawing. Cross, touch, cross. So that is my graph. This is my graph. All right. Okay, these are generally how do you draw the graph. if you can factor it, then it's quite convenient. If you cannot factor it, then you must do a table values. Okay, this is about given the function and how to draw. So let me summarize it. If the function is given, then try to factor it. If you cannot factor it, then you use the table values to draw point by point. You have the table values. The table will give you many points, and you locate the points on the xy plane, and you join the points, you have the graph. If you can factor it, then it may be easier. Then x-intercept is found by letting each factor to be 0, and you can find the x-intercepts. And then again you find the y-intercept. Once you have the x-intercepts, y-intercepts, and you have the information whether the leading coefficient is positive or negative, then you can draw the graph qualitatively. Yeah, qualitatively is the shape, but you have several points, x-intercept, y-intercept, precisely determined. So using the points and draw a qualitative graph. So that's how you draw the graph. The next thing is the reverse of this process. If you have a graph, how do you find the function? If the graph, sometimes the graph is not given to you directly, but instead a table of values is given. The table is given. Because the table means a graph, so I can also say a graph is given. So let's have a given table of values and then see how we can find the function. For this part, I have a written page. Okay. Actually, what I'm talking about is in the textbook advanced functions. So this is 1.2 polynomial. Now, the table of value is given. I write the table of value in this way. X, these are x values. You must notice that x values decrease by 1 every time. From 4 to 3, it's 1 less. And you decrease by 1, you get 2. Minus 1 again, you get 1. Minus 1, you get 0. Minus 1, you get negative 1. Subtract 1 again, you get negative 2. Subtract 1, you get negative 3. These are the x values. The corresponding y values are these. Now, this table must be given. I want you to pay attention that the x values, the neighboring x values, have a constant difference, just 1. You can have a difference of 2, but then every time you subtract 2, okay? In other words, the difference has to be the same. Now, once you have the x and y, you subtract the y, you find the difference of y. 48 minus 18 is 30. 18 minus 4 is 14. 4 minus 0 is 4. 0 minus 0 is 0. 0 minus negative 2 is positive 2. Negative 2 subtract negative 12 is 10. Negative 12 subtract negative 36 is 24. This line is the difference of the y value. And we call it first difference. Why do we call it first difference? Because we are going to find another difference. So go down to the next line. This minus that is 16. 14 minus 4 is 10. 4 minus 0 is 4. And so on. This minus that is this minus that is this, and this minus that is this. So this is again a difference. But this difference, we call it second difference. We continue. This minus that is 6. This minus that is 6. This minus negative 2 is 6. Negative 2 minus negative 8 is 6. Negative 8 minus negative 14 is 6. So this is the third difference. Look, the third differences are all the same. Then you stop. Let me say it again. From the table of values, you find the difference of the y value. Find the difference. If you see the differences are all different, they are not the same, then proceed to find another difference. If these differences are not the same, you go ahead, find another difference. So you continue until you find the differences are all the same. Then you stop. These differences have a name. It's called a finite differences. Finite differences. So you want to find finite differences all the same, then you stop. Now in this case, the third differences are all the same. This tells you that the degree is 3. The degree is 3 means the highest value of the exponent is 3. And this positive 6 also tells you that the leading coefficient is positive. But you don't need to worry about that. Let's write down the general expression of a degree 3 polynomial. This is the general expression of a degree 3 polynomial. This is the exponent. This is 3. The reason this is 3 is because the third difference are all the same. So I have this. So this is my polynomial function. The next, I must find what A is, what B is, what C is, and what D is. I have 4 unknowns. To find 4 unknowns, you need 4 equations. How do I find 4 equations? It's from the table of values. When x is 4, y is 48. That's one equation. When x is 3, y is 18. That's another equation. And so on and so forth. So I have many equations from table values. 1, 2, 3, 4, 5, 6, 7, 8. I have 8 equations from the table values. But I only need 4 to determine the 4 unknowns. So I choose 4 among the 8. Of course, I don't want complicated calculations. I choose the simplest 4 equations. I see this 0, 0. 0 makes the equation simple. So I choose 1 equation here, 2 equation here, 3 equation from here, the 4th equation from here. These are the simplest. Okay? So I have 4 equations. I choose these 4 points. From 2, 4, which means x is 2, y is 4. So y is 4, x is 2. 2 cubed is 8. So I have this equation. From this point, x is 1, y is 0. So y is 0, x is 1. This point is when x is 0, y is 0. So I have this equation. From this point, when x is negative 1, y is negative 2. So I have this equation. Look, d is 0. Therefore, this d is 0, d is 0, d is 0. Then I have 3 equations instead of 4. I have 3 equations in A, B, C. Because d is already known. So I have 3 equations. Here. First equation, second equation, third equation. So from the 3 equations, I can find ABC. So this is what we want to do. So I go to next page. You add equation 1 and equation 3. You add equation 1 and equation 3. You see, when you add, the positive c and negative c cancels. C is gone. And the 2 and negative 2, if you add, you get 0. And so you add the A term, add the B term. So add equations 1 and equation 3, you have this equation. This equation can be simplified. 3 can be factored out. Then the result is 0 is A plus B. A plus B is 0. Look here. A plus B is 0. Therefore, C is 0, right? From this equation. So now I know from equation 2, C is 0. C is 0. Let's go to the 3 equations. C is 0 now. So I know C is 0. This is 0, this is 0. So I have this and this. Then I add equation 2 and equation 3. I add these 2 equations. So it's negative 2. This plus that is 0. This plus that is 2b. So 2b is negative 2. So I get 2b is negative 2. This means b is negative 1. If b is negative 1, because a plus b is 0, so a is just 1. So I have a is 1, b is negative 1, c is 0, and d is 0. Therefore, the function is y equals x cubed minus x squared. So this is how we find the unknown, a, b, c, d. From the table of values, you can pick points so that you have just enough number of equations to solve for the same number of unknowns. This is how you do it. So if you follow this example, I want you to practice this question. The table of value is given, then what is a function? Just follow the steps of the example. You can do it. Now this is a little longer. The process is a little longer. If you have a computer and you have a software called decimals, you can use the decimals and you just enter the table. And the decimal will tell you what the function is. It takes you only a few minutes. So this is a shorter way, but if you do that, if you use decimals, so you are not using the algebra. Huh? This is algebraic way. If you use decimal, it's quick, but you do not use algebra. Maybe sometimes you forgot how to find without decimal. Okay, so you need to know both ways. I advise you to practice finding the function from the table of values using algebra. And I also advise you to practice decimal. That's a software. You do that. Okay. These two remarks are just tell you the relation between the leading coefficient and the degree. The leading coefficient and degree has a relation, which I wrote here. The leading coefficient A times the factorial of the degree. N is the degree. This label is factorial. The n factorial multiply the leading coefficient is equal to the value of the constant finite difference. So this is the relation from which you can find the leading coefficient. However, the above algebra method also gives you the leading coefficient. This is just a relation from which you relate the relations between leading coefficient and the degree, the value of the degree, and the constant finite difference. Good. This is what we have for this lesson. Goodbye, and I see you next time.